Welcome back, friends. Today I will be discussing Python libraries, and we will also see that Jupyter notebook further. And this blog is in continuation with my last blog related to the data structure techniques we discussed, and directories and set, understanding the difference between all data structure techniques. I also discussed about different installations options and overview of Python Word. The key takeaway from today's session will be Python control and loop commands with C. I will discuss working of Jupyter notebook and will provide brief introduction of Python core libraries using the same Jupyter notebook. So libraries normally used in data science and engineering, those kind of things. And this, whatever comparison we are providing in terms of C, we are not covering C from day one. So if somebody is interested, we have a separate provision for that, and you may contact us through embedkari.com. You will get that email ID there, embeddedcareers.ind@gmail.com, and we can provide that free demo video of that, and that we provide to our subscriber. So please subscribe with a valid email ID, and so that can be validated. And in C, basically, you know that simple if general statement, like if whatever the condition will be there here, if a is greater than 10 or any condition test expression, then some statement do this, that, print or whatever action. Then optionally can be further else if, or can be last else, or maybe optionally can be this, for example, this plus this else, or a long list, or depending on that, or conditions, and or this. So in Python, the conditional operators are same, like equal to, not equal to, greater than equal to, less than equal to. These symbols are shown here. The general format in Python, as we have discussed also earlier, these things. So if text expression, and then simple text expression, then colon you have to do that, and after that statement 1, then elif it will use if you are going to use further else statement. If you are not going to use, then probably this first one itself is fine. Or if you want simply two statement, if else, then if this, or simple similar to C, else, only the difference is colon is here. So this is the difference between C and Python if condition. Let's look into for loop. For loop, in C, for is initialized. For example, if you define some variable integer I equal to 0, then you check the condition I is less than 100, something like that, and then you modify I plus plus, and you do whatever you want within the for loop, different statements. In Python, we use like this: for value in sequence, and then colon, and then statement. So here is the example: for x in range 1 to 5. So this is similar to for integer x equal to 1 or x less than like 5, and then x plus plus, similar kind of thing. And then this is the statement. So this is the for loop, simple. And while in C, simply while condition and statements are here in Python, while test expression and colon and statements. So almost similar. And similarly, like break and this continue commands, whatever we use in C to break that flow of that particular loop or continue in the loop. So same thing we see in the Python, and that exercise on these we will do in basically when we will do some practical big exercise in that custom functions later in some other session. Then we'll utilize these things. Today the idea is to understand in addition to this simple expressions comparison, to understanding, okay, this is the if condition we can use, this is while condition we can use. So this is the just understanding break continue you can use. Similarly, you have to have understanding of different kind of code libraries, and then we will keep adding this other things related to language and interesting thing related to Python. Lot of other interesting things in the Python. This is just a basic introduction. And so code libraries we use in science and all that. So this is called SciPy. And if we go to, I have provided the link, is a Python based open source software ecosystem for mathematics, science and engineering. So if you go to this link, so you will see that what it contains, like NumPy, this SciPy libraries, these things, Ipython, SymPy. So today we will look into this with simple examples. There are complex things are already available, that I will also show you. But today the idea to understand that how simply we can understand this. For example, let's say NumPy. So what I have done, if I have provided the link to this SciPy, then from there in this link it provides the information related to what is the purpose of this, and then you will find home page and download. So anyway, that these libraries already part of our this Jupyter notebook, so we don't need to download now again. We have done in that Anaconda. But home page you can try, and you can see further. If for example, if you want detail on, if you are interested in NumPy first, the tutorial, you can see the complete detail here. So okay, different examples are given to play with this. So it depends like where we focus. So NumPy is basically, you can think of that base of this numbers you will need everywhere. So this will be mixed with others also. So it is used for scientific computations, means that array number means like array kind of computations you will require other places also. We'll see that scientific computation where large multi-dimensional arrays, matrices and high level mathematical functions are used. Mathematical functions are used. This is the NumPy and the Python based. And second is SciPy. In that utilizes NumPy, fast array, and it provides efficient routine for integration, optimization. You will see a lot of other libraries, for example, SciMath of this, it utilizes that. So these are like each of these is not that simple. It looks like this, each of these can be discussed separately, and depending on that our focus. And this is important, like Matplotlib, And the licenses I have provided that this is the BSD license, so specific license link I have provided for this library, and all are open sources with certain conditions depending on the licenses or certain restrictions. And this it is the Python 2D plotting library to generate publication quality figures. So here I have provided, for example, if you go to this particular link, so you can have idea of that how you can this is the example, good example of this, how you can plot, utilize all these loops and all those kind of stuff, random number, and finally you generate a thing like this, dolphins. So this is one thing. This is that apart from that, lot of other plotting options are there. So this is one example, but I will show you very simple circle based first, that how it works, and also like that each of these, as I told you, has large scope of depending on that our focus study. For example, in this case, artist API in this Matplotlib, and you will find different options. We will see, for example, we can use for patch for our primitive figures. So let's say circles through the patch. So how we will utilize that, one example I will provide you, and later we will see that how we can utilize it. And this is basically written originally as a Python alternative to this MATLAB. So you will see that much of the syntax related to that. And SymPy is, this is the another interesting fact, and in Python library. So again, SymPy also have provided the link to that directly SymPy, and this is the free open source, and all that kind of information, source code, everything is given here, so one can go inside and look into that code also. And here for symbolic mathematics, so if you remember, like computer algebra system, where you use lot of what, how computer work with the, how parser generate these kind of syntax trees from the parser. So in the computer science, for example, this is a simple example of a plus b, and this formula, let's say into C. This is the normal algebra, we use that, but how the computer will behave, computer will take based on this of different operators. So this operator as a root, okay, because the brackets are there, and this is the part of this computer algebra, and then it will take these two as a separate children of this, you can say root or parent, and these are children, and then within that a b, then this plus token it will take. So this way it will basically, in computer algebra it will work, computer work like that only, that all kind of lexical analysis or those kind of stuff comes into the picture. So that kind of handling is done by SymPy. For example, let's say under root 2, normally if you take the root 2 value is not whatever the value comes of the root 2 may not be that, if you use the decimal value may not be the exact. So but maximum time, if you can utilize the symbol in the calculation, that may help. And that kind of thing taken care of SymPy itself, a big chapter. And Pandas is related to that data structure, data analysis tools of this, and Ipython, as I told you, for interactive it is interactive cell, and today we will see that its utilization for visualization. We'll try to see whether we can play the YouTube video with that, so that we will see. And apart from that, Anaconda navigator, this is another thing. Like this is that GUI kind of representation. Within that you will find Jupyter Lab is also there, is interactive development environment, and advanced than this Jupyter notebook. But for beginners I recommend Jupyter notebook. And in the industry also people using this Jupyter notebook, and in many projects. So this I will show you that Anaconda navigator. So within Anaconda navigator, so how to install that, you will find like Jupyter notebook and all lot of other things. Even our studio you can install and launch from here. So here I can show you like the same thing you will get from the Jupyter notebook if you use the GUI base. So you will use this only, but I am right now using command line only. From the command line, as I told you last time, Jupyter notebook, I am just typing in the command line and utilizing that. And how to install that? In the last, if you have done Anaconda, just you use this instruction, conda install, and this Anaconda and this navigator. So this will install that particular thing. Now if you look into the Jupyter notebook, so you can have think of analogy with the modern advanced software scientific calculator. If you see the like hardware scientific calculator, we used to have lot of functions, trigonometric function, log function, everything in the scientific calculator. But now it is coming with an advanced version where we put the documentation, we see the live, so I can think of it as a next gen software calculator, just analogy for the sake of analogy. So let's do like practical today. And I would like to take you through this. I have already done a lot of things here. I will show you that how it is. First of all, just recapture that what we have done last time. List represented by simply bracket, square bracket like array in C, and the tuples by this parenthesis, then element. And just keep in mind these things and dictionary like this. So these will be that element used in different libraries. Another thing we did not discuss so far, the lambda function is nothing but simple functions. For example, if you define a function and other, here you will note one thing. I have provided this is the documentation here. If you click on this, you will find this. As for this is for basically that anything putting in that from here you should be able to heading. Then if you put this hash, then it will highlight this, okay, for the heading. So here, like if you define multiply a function, this kind of function, and return value is this. If you same thing you can do in Python. Define, if you write lambda and xy, then x into y, so it will return. So you can simply use this mul function as multiply function 812, and it will give the result. And here you will see that these basically called markdown. You see that you can change it from here. If I come here, you will see the code. So if I run from here, for example, last time we have seen the kernel and restart and killer output. Okay, then it says, okay, some warning, this, it will clear the value and all that. Other thing you will note that here, once I click here, the right side, you will see this, edit mode. And here, you will not see the edit mode. If I enter, then it will go to the edit mode. It will go to the edit mode. And similar thing happens with, if you click here, it will show you the edit mode in the code. So if I run, let's say from start, so it will not do anything here. This is just for it that marking our documentation, so it will not that way it will not execute. So this let's say simple execution of this, so it will give you the output. Okay, so this is simple lambda function. After that, let's come to the NumPy, that array package. So in that array creation example, simple I have given like NumPy, you can import in this as a NP, and then because I have imported this here, so I will not import again below, and it is being used many places. And here simply one array we have defined, and if you put a, then okay, I will show you the execution, then we'll understand. So first of all, let's say a, we will print a. So a is now array this, and just to make sure that okay, is it somewhat similar to our list kind of terminology, indexing, negative indexing, because the components would be same. Let's see the value. Fine. Then SciPy library for integration and optimization. So I have given one example. Let's say algebra equation. This is the 3x plus 4y 26, 8x plus 8x minus y 11. You have to solve this algebraic equation. So we will use this SciPy, and SciPy use this NumPy. So here solving this linear example. So what we need to do? SciPy import this, and already we have imported this. That's why I told you that I will not import it again. Then here create array of the left side element. Left side means this 3, 4 and 8 minus 1, and then on the right side, and then finally you see the result. Solve these two, so it will print the result. Let's see that how it works. And so you will find the value of this. And for example, if you change anything here, let's say if you change suppose if you change this element 4 or something, and then if you run it, so you will see that immediately that value will change accordingly. Okay, so that is that flexibility of this our modern scientific calculator. And second is like let's see this Matplotlib. Here basically it provides basically pyplot we will use. So it provides this interface to this library functions, and in the beginning you will see that I have used this inline is basically notebook causes the plots to be in the static images. So if you don't put this line, so sometime you will see that it is showing this rendering is proper happening, sometime you will not see. And you can use this also, notebook also, Then let me try to run it, and here what it is doing, importing this pyplot, the axis, then you will find that this is the circle center, and then radius, and then color, yes or not, and then it is getting that current axis, and then using the patch. I told you that circle, from the patch you can have the primitive shapes like circle, rectangle, and then again this scale to that level, that I will show you that what is the difference, and then so, and I will run it. So this you can see that how it is being scaled to that. Suppose if I use the equal, you see the change between these two, and let's say I use equal, and then I execute again. Now you see the difference in equal 0.5. So that kind of scaling and those kind of features are also part of this. So idea is that this particular will give you a lot of flexibility in terms of plotting bars, plotting curve, plotting scientific waves, and a lot of other things that is possible with that. So that detail is separate thing. And that SymPy, I discussed with you that like computer algebra. So it represents the, for example, this function I have shown you that this is that the parent, and this is that these two are the children, or here we call the arguments, or this is called the root. And then if I go here, so again you have to SymPy, you have to import, and star means you are importing everything, all functions from that particular, and then ABC you are defining as a symbol, and then function you are defining this. Then let's see how it is showing that type. This is the SymPy code library type, and then let's try to see the argument, means it will show you that children of the root and C and A plus B, that's fine. Okay, the way the computer will take that elements right to left, and then, and this is that individual print argument. First argument it has taken this, second argument it has taken this, that's why printing is done. Okay, then let's go to further Panda. So Panda is for data structure. So where here we have basically initialized, let's say we have a create a series from the dictionary. We have a dictionary here table. I simply like import pandas as PD here, and the dictionary you can see like 2 to 4, 4 to 8, simply each is multiplying. So how we can make a series out of that using the data structure Panda? Then my series is, then make a PD is this, and dot series, then pass this data. So you will see the result what it does. So it has created a corresponding series here. Okay, and data type also. So apart from that, Ipython, I told you that this is another element here, the YouTube video display. So in that we have simply import the YouTube video from the Ipython display, and that I provided, basically this is the complete embedded URL of that particular video. So this part I have to provide because it already, it is this is aware of this is the YouTube video, so that's why I don't have to provide the complete here. And this is different from that another format we use, that HTML, where we have to provide the complete YouTube video. So let me try to run it. So here you can see like that complete YouTube video. Yeah, so this is that complete video. Okay, so this is all about the quick introduction to different important aspects of this Python, and especially this particular notebook. You can see that I have documented. At the same time we have experiment also. We can anywhere we can see we can run it, or we can start anytime, restart and clear output, and we can from the beginning we can run it, and a particular cell also you can run, and we can break that one particular function, like one particular sequence in different cells also. That is also, that flexibility is there. And we can mark down, and if suppose if you create any cell here, let's say if you insert, you can insert a cell from here, insert cell below, cell above, let's say like this, and then within that you can change this particular to markdown. And if you write something here, and then if you use this, or you can simply what you need to do, it is not taking. So let me show you that if you do heading here and okay, so this is the way we can use. Let me go back to that point again, and so if you like this quick overview through this, so please like the video, and if you have not subscribe to this, and I will be soon posting more videos, and this is just a base actually. After that we will see further where we can go, OpenCV, computer vision, or whatever. We'll see that based on the interest of that subscribers, and if you need to find the open source related tools and technologies, you can check this particular link also. Okay. Okay, thanks for your time.